Hello champions, welcome to Deeksha Karnataka. Just let me check whether I am audible and visible or not. Then I will start the class. Just give me a moment. Yes. So yes, so we have completed our bridge course. I hope you have seen those two classes where I have basically discussed basic mathematics, which will be very helpful and beneficial going ahead, because none of the concept that we are going to discuss, we will assume that you already know those concepts. Okay, if you are someone who is weak in mathematics, if you are someone who forget some of the mathematical concept from lower classes, then do check those out in your spare time. Not very long lectures, they are less than 1 hour, right? So do check them out, and 1 hour each, hopefully that will be very beneficial if you are someone who is preparing for KCET, right? And if you are watching me live right now, you can post your comments. Just let me change it. Yes, so you can post your comment in the chat box. I will try to address as much as comments as possible, right? So let's start. So first we will basically show you what are all the chapter order. So chapter electric charges and field basically can be divided into multiple portions. One is electric charge. Obviously electric charge itself is a topic, and from electric charges we have conductors, insulators, basic properties of charges, etc. We have also have Coulomb's law. Then we have electric field lines. We have electric dipole moment, electric field due to a dipole in an external field, electric flux, charge distribution, Gauss's law, applications of Gauss's law as well. So these are the basically the topic tree of the chapter. Now in today's lecture we will be basically discussing everything that is written over here. Okay, everything that is written over here. Okay, and something extra as well in detail. Obviously not everything is possible to write over here, but yes, we are basically discussing electric charge, properties of electric charge, okay, charging by induction. Then we will also discuss the conductors and insulators. We will also discuss Coulomb's law. Electric field and electric dipole, these two will be discussed in our part 2, and electric flux, Gauss's law, etc. will be discussed in our part 3. This is the chapter structure. So 3 parts will be there for this chapter, and then we will also discuss KCET PYQs from this chapter as well. So those who are preparing for KCET, obviously you have to practice PYQs. So KCET PYQs will also be discussed once all the 3 parts are over, right? So let's start. First is electric charge. So whenever we say electric charge, you always assume that it's basically either electron or proton, because we already have the idea of electron or proton. But electric charge itself, when it was discovered early 18th century, okay, it was not known what is the what causes these things. Okay, so the Coulomb's law was even given without knowing the actual nature of the charges. Okay, so the nature of the charges came early 19th century, almost 100 years later. The existence of charge was discovered. Okay, so that's why electric charge is not always electron or proton. Even without knowing whether it is electron or proton, we can actually discuss electric charges. And how electric charge is described? So in physics, charge refers to the fundamental property of matter that causes it to experience an electric force when placed in an electric field. So here it is a star mark is given because we will discuss about electric field in later part. Okay, so basically you have heard about fundamental properties such as mass, volume, okay, atomic number or mole number, right? Similarly, charge is also considered as a fundamental property. Okay, now there is slight, we have 2 types of properties, physical properties and chemical properties. Charge is basically comes under both of them. You cannot say that it is only chemical property, or you cannot say it is only physical property. Okay, both of them actually influenced by the presence of charge. obviously. So chemical and physical both properties, property combined is part of this quantity. Okay, so charge is a physical quantity, but the unit of charge is not fundamental. By the way, we will discuss that as well. So everything about charge we will discuss in today's lecture, right? So now there are two types of charges. Okay, we all know this, nothing new to us. Positive charge and negative charge, right? Positive charges and negative charges, not proton and electron, by the way. Proton and electron are two particles which are different than positive charge and negative charge, right? So positive charge, it can be may not be a proton, single proton. Positive charge can be less number of electron as well. We will discuss that, come to that as soon as our next part. Okay, so there are two types of charges, positive charge and negative charges. Now very basic property of charges, it is very basic property, not basic property, that like charges repel each other and unlike charges attract each other. Okay, in your PU board exam sometimes it being asked write three basic properties of charges, and many students write these properties. These are not actually comes under the basic property of charge. This is like a fundamental property of charge. Okay, this is the fundamental property of charge, not basic property. Basic property is different than this. Okay, so like charges repel each other, unlike charges attract each other. So this is graphically shown over here. So one charge is positive, one charge is negative, and they are basically attracting each other. So opposite always attract, similar always repel. Okay, that is the law of nature. So positive, negative, they attract each other. Positive, positive, they repel each other. Negative, negative also repel each other. Very basic, very fundamental thing. We are not doing anything new as of now. In a neutral object, positive and negative charges are balanced. So as I said, we will come to the part where proton, electron, etc. are discussed. So in a neutral object, positive and negative charges are balanced. Okay, that means if you consider an atom, basically all objects are consisting of a very fundamental particle which is called atom. That was atomicity. Okay, so atom initially was thought it is indivisible. Okay, that means you cannot divide atom into further parts. Okay, but later on Avogadro and some other people came into picture, and not Avogadro, sorry, Rutherford and J.J. Thomson came into picture, and they discovered that atom is not indivisible, but they are consisting of even smaller particles. Okay, one of the smaller particle is called electron. Electron was the first discovered. Later on we discovered few more particles, namely proton and neutron. Okay, so basically these three particles are fundamental units of or elementary units of a atom. Okay, atom itself consists of electron, proton and neutron. So protons are positively charged, electrons are negatively charged. Okay, in an atom, okay, atom by default is neutral. An atom is by default is neutral. That means it has equal number of positive and negative charge. Neutral does not mean the charge is zero. Neutral, first of all, very fundamental concept you have to remember, neutral does not mean the charge is zero. Okay, but it means if some object is neutral, okay, then it means the positive and negative charges are equal. Positive and negative charges are equal. Okay, it does not mean the total charge is generally we say that net charge is zero. Okay, net charge is zero, but that does not mean it does not have or consists of any charged particle. It do have charged particles. Okay, only thing is charged particles are balancing each other. That's why the net charge is zero. It is very, very handy in future going ahead in other chapters as well, in current electricity, in semiconductors. This concept is very, very far reaching, even though it appears to be very simple. Still, if you are not very confident about this, you make mistake in future, right? Hello, it's Akash. Hello, it's Akash 551. Hi. So if you have any doubts, any questions, do mention that in the chat box. I will try to reply all of your comments and questions. Okay. Now to charge a neutral object. Now the question is, how can we charge a neutral object, right? To charge a neutral object, we have to do something. What we have to do? We have to add or remove one type of charge. To charge a neutral object, we have to remove one type of charge. Okay? You cannot remove or add both of the type of the charges. You can either remove or add one type of charge. That charge is electron. Okay? Only electrons can be added or removed. Okay? Only electrons can be added or removed. Protons and neutrons, they are sitting quietly, tightly at the center of the atom. That is called nucleus. Okay? Generally, to break the nucleus, to make the protons free, you require a lot of amount of energy. Yes, it is possible to break the atom. It is possible to release the proton, but that is not what we are looking at, especially for this chapter. Okay? That comes under a complete separate topic, complete separate section of physics. So we are not discussing that. Charge, whenever we say charged object, basically that means we have added or removed some electron. So by default, obviously positive and negative are equal, but if you add some extra negative to this, if you add extra negative to this, what will happen? The positive's effect will reduce, the negative effects will increase. That's how you charge an object. Right. So to charge an object, you have to add or remove electrons. So if you remove some of the electrons, what will happen? The effect of positive will increase, effect of negative will decrease. That's why if some object is positive, that means it has less amount of electrons. If the object is negative, that means it has more number of electrons. Okay. Sir, this re-NEET will more difficult paper. Reply. So the re-NEET paper, we have no idea. So it can be difficult, it can be easy. Okay, as I mentioned, I have discussed in one of our future videos that NEET exam basically prepares 4 or 5 different sets. Okay, one set is leaked. Okay, they have a few more set ready. Okay, and one of the set might be they will redo the exercise because someone involved in the process of making the paper itself leaked the paper. So maybe they might make new papers, and generally paper levels will be same. Now difficult or easy is irrelevant, because if it is difficult, remember one important thing, it is difficult for everyone. Okay, I always say this to my students, that if you think the paper was difficult, remember it is difficult for everyone, it is not only for you. So it is immaterial if it is difficult or easy, right, Akash? So if you are prepared, then it does not matter whether it is difficult or easy, but main thing is you have to prepare. Preparation is important, not the results. If you are prepared well, okay, even if it is difficult or easy, unless, yes, some topper students means those who are class toppers, they might strive on a difficult paper. But for most 90% of the students, those who have prepared, those who are preparing seriously for a NEET exam, okay, out of those, if paper is difficult, it is difficult for everyone. Okay, so average cutoff will reduce, everything will reduce. So don't worry about whether it will be difficult or easy. You just focus on your preparation, that is sufficient. All right. So don't overthink whether it will be difficult or easy. Now where we are discussing about electrons. So if you want to charge an object, you either add electron or remove electron. If you add electron, the object becomes negative. If you remove electron, the object becomes positive. Electrons are negatively charged elementary particles. Elementary particles means it is considered the building block of an atom. Okay, there are even more fundamental particles than electrons in modern theory, modern atomic theory. Okay, but we are not going to discuss that over here. This is not atomic theory. We are discussing about basic particles, and electron is the elementary particle which basically consists, which is one of the building block of an atom. Okay, if electrons are added to a body, it gets negatively charged. If electrons are removed from the body, it becomes positively charged. Sorry, this is a typo. Okay, so if you add electron, it becomes negative. If you remove electron, it becomes positive. There are two types of charges. I think this is already discussed. Oh, sorry, instead of going forward, I came back. So now, how can you detect if the object is charged or not? So gold leaf electroscope is a device. You have studied about this in your lower classes, gold leaf electroscope, okay, which can measure the presence of charge. Okay, so it is a device which can measure the presence of charge. Exact amount of charge may not be possible to measure using this. For that, you have to calibrate the gold leaf electroscope. Gold leaf electroscope basically consists of two very tiny thin leaf-like, paper-like gold foils, okay, and there is a conductor like this. It is put inside a glass jar. Okay, design can vary based on obviously the equipment, and the jar is now grounded. Okay, the jar is actually grounded. Now, if you brought a charged object near the gold leaf electroscope, by the method of induction, we will discuss the induction method. By the method of induction, what happens is that the gold leaf spread, and because of this spread, you can say whether the object is charged or not. If the object is not charged, gold leaf will stay as it is. If the object is charged, gold leaf will spread. Okay. SI unit of charge is Coulomb, and dimension of charge equals to A into time. A is ampere, T is time. Now, as I mentioned, charge is not considered as a fundamental unit. Okay, in terms of unit, current is considered fundamental. Okay, now don't ask me why. There are a lot of reasons behind it, but major thing you have to remember: charge is not a fundamental quantity, but current is. So we know that current is charge divided by time. So charge is current into time. Okay, so charge is current into time. Now let's move forward and discuss charging by induction. So what is the meaning of charging by induction? So you have, there are the method that you can charge an object. There are two methods: charging by conduction, charging by induction. Charging by conduction is what? So what is charging by conduction or charging by contact? Okay, charging by contact. So charging by contact, so this is, let's say this is contact method. Contact method is what? You have a charged object and you have an uncharged object. Okay, you have a charged object, you have an uncharged object. If you connect them using some conducting wire, some charges from this object will flow into the second object. Okay, now this second object will also be charged. Okay, so this is the method of contact or charging by conduction. Conduction obviously it refers to a contact, right? Now what about charging by induction? So charging by induction is very interesting process where we have a charged object. So charging by induction is this one. So where we have a charged object and we have an uncharged object. Okay, uncharged object, and there is no contact. Here there is no contact. Okay, so the contact, so either you contact them using some conducting wire, or you bring the charged object near an uncharged object, but you do not keep them in contact. Now what will happen? So this object is basically consisting of positive and negative charges. This object is made up of positive and negative charges. Generally it happens in case of conductors only. So you have a conducting material, obviously this is a conducting material, and when you brought a positively charged object, it basically attracts all the negative charges present inside this conductor towards it, okay, or whatever electrons are present inside this, they get attracted towards the positively charged object, and whatever the protons are there or the nucleuses that without the electrons, they get repelled in the opposite side, okay, they get repelled in the opposite side. So this is called induction. Now there was a PU level question where it was asked that if you remove this positive charge, what will happen? So if you remove this positively charged object, the original object will go back to its original state. Give me a second. So if you remove this object will go back to its original state, that is neutral. This object will go back to its original state, that is being neutral. But that is not our goal. We want to keep this object charged. If we want to keep this object charged, what we can do, we have to, now one more important thing, that as long as this object is present, these negative charges are not able to move. They are fixed with this positive charge. These charges are called bound charges. These charges are called bound charges. They are called bound charges. Okay, whereas the charges which are associated on the other side, they are free charges. They can move. That's why they are called free charges. These charges are bound to the source charge. That's why they are called bound charges. They are not allowed to move. Now if you do a very simple thing, that you ground this object. You can ground it anywhere, does not matter. You can ground it. Suppose it gives an impression that I am grounding on this side. So if you ground this conducting object, what happens? Some electrons will flow from this side and they will neutralize this side. So basically what will happen when you ground this, let me change the color again. So when you ground this, what happens is that these positive charges, they gets neutralized, okay, because some electrons flow from the ground and they only neutralize the free charges. They are not doing anything to the bound charges, because bound charge cannot move. So bound charges will remain as it is, the free charge will disappear. Now if you remove this source charge, the excess charge that still remains on the body, they now distribute themselves among the object and the object becomes negatively charged. Okay, so the object becomes negatively charged. Now there are one more method of charging, charging by friction. Charging by friction is not part of the syllabus. I am not discussing that. You have studied in your class 6th or 7th standard. Okay, so there was a table. In that table, if you rub the top object with the bottom object, generally the bottom object will become negative, the top object will become positive, like that. Okay, electron affinity table. Okay, so the object in the bottom, they are more electron they have affinity higher than the top objects. That's how it worked, right? But that we are not discussing in this lecture. If you want, you can mention that in the comment below. I will try to make a short video later on and I will add it along with this, right? Now let's move on and discuss our 1 whole year KCET paid batch. So we have launched 1 whole year KCET paid batch, Pariksha Veera. Okay, what is Pariksha Veera? Pariksha Veera is basically live plus recorded classes by masters teachers, live in class doubt solving. So we will not only give you live classes. Yes, hi Bhuvi King. Hi, hello. Live plus recorded classes by master teachers, live in class doubt solving, complete first PUC and second PUC syllabus coverage, 20 plus part and full length tests, okay, for KCET 2027, and teacher notes after the class. You will also get the class notes, DPP generator. So you will get a DPP generator where you can access thousands of daily practice questions. Pedagogy app through which you can access free ebooks as well, okay, and price for that course is only 3499, only 3499, not 5999, not many colleges and courses they offer at much higher prices. We are offering it a nominal 3499. It's a 1 year whole course where we will be taking care of your PU exams, PU syllabus, your KCET syllabus, okay, everything will be taken care of, and you will also get tests, mock tests, you will get daily practice papers, the teachers will be there to clear your doubts, so everything will be there. So if you are someone who is looking for a structured way of preparing for KCET exam, then definitely you should join our Pariksha Beta batch. The link of Pariksha Beta batch is given in the description section. Close the live chat and you will find the description of this in the description, right? Yes, so if you have any doubt, any questions, you can ask me in the chat. As long as I am here, I will try to answer, right? Conductors, charges can freely move through them. So now we are going to discuss about the two types of materials, namely conductors and insulators. There is one more type which is semiconductor. We will discuss that in future, okay? So conductors, charges can freely move through them. A conductor has a lot of free electrons to carry electricity. So basically conductors are those, we know, metals, okay, graphite is one of the non-metallic conductors. So basically they are used to conduct electricity. That is their major purpose. So if you give any charge to a conductor, it will flow through them. It can flow through that conductor. That is the major property of conductor. Okay, now all conductors are not same. Some of them are slightly better conductors, some of them are average conductor, but all conductors, they have one thing in common, that is they have lot of extra, lot of free electrons. Free electron means you can easily remove those electrons, or you can easily add some extra electron to the conductor. That is the major thing, okay. So addition and removal of electron is easy for a conductor, okay. Charges given to a conductor always lies on the surface of the conductor. So if you add some charge to a conductor, charge will always stay on the surface. It will not go inside the surface. So imagine a plastic ball floating on a water, okay. Imagine a plastic ball, if you drop it in a water, it will float in the water. Even if you try to put it down, it will come back again, right? So this is basically like a conductor. So conductor is where charges reside on the surface. It will not go inside. Next are insulators. So insulators are the thing that we use in our day-to-day life. Both conductors and insulators, both are important in our life. We use, without insulators we would be getting electric shock every time, but that we do not get. That means insulators are those which protects us, okay. Charges cannot flow through them. They have almost zero free electrons. So they are not, first of all you have to understand, they are not having zero charges, only free electrons are zero. Net charge is zero, okay, but they are not have zero charge. They do not have zero charge. Very important part. They do have charge particles, but positive and negative charge particles are equal. That is very important point to remember, okay. They do have charges, but positive and negative charges are equal. So net charge or total charge is zero, okay. Sometimes these terms are very confusing, I know. At the beginning, charge. It can be little boring and can be little frustrating for you, but you have to understand these very basic concepts, then only you will progress, right? Now, examples of insulators are plastic, paper, non-metals, etc. Okay. So, we have seen plastic, we have seen paper, we have seen non-metals. Most of the non-metals are insulators. There are few exceptions. Now, you have seen this kind of lamp posts or electric poles, right? Now, you may have thought that if I touch the lamp post, I will not get electrocuted, even though most of them in the city, they are built using metals, right? But we do not get electrocuted when we touch them. Why so? Because there is a very cute mechanism that is used. So, this is the live wire which carries the current, and then they are connected using this kind of insulating mediums, and this insulating medium is now connected to the lamp post. Okay. And again another insulator is connected on this side, and then the live wire goes. Now, from where the current will be carried, because both sides are disconnected, right? So, that is why they have hanging wires. Okay. This hanging wire avoiding the lamp post carries the current to the other side. Okay. So, this hanging wire basically carries the current to the other side. That is why the lamp posts are generally safe. But during the rain, during some storms, if this hanging wire touches with this lamp post, then there might be cases of electrocution. So, do not touch lamp post, even if it is quite safe. You should not go very near to the lamp post, because during the rain, especially during rain and during storms, this wire can touch the lamp post, and there may be cases of electrocution. Okay. You may have heard that someone got electrocuted because of some electric wire or lamp post touching the lamp post. So, do not do that, stay away. But in general, even in normal days, generally it is safe. Generally it is safe, but why go near a potential danger if you know that it might be dangerous, right? So, do not do that, but there is a way to safeguard these things, right? Now, let us move on. Semiconductor conduction depends on temperature. We will discuss about them in our future chapters, not in this chapter. Some part we will discuss in current electricity, and later on in the semiconductor chapter we will discuss in detail about semiconductors. Okay. So, conductors and insulators are there. Okay. Conductors are of free electrons, insulators have 0 free electrons. Semiconductor is in between conductor and semiconductor, that is why it is called semiconductor, but there are other things involved with it that we will discuss in our future video. Okay. Now we are into the main part, where we are discussing basic properties of charges. This is very important, be it PU exam, be it your first unit test, be it your midterm exam, be it your half yearly exam, okay, or your selection exam, or your final board exam. So, or KCET exam, everywhere this is a very common and important concept from which you can expect questions. In PU exam, so definitely there is one very common question: write 3 properties of charges, write 2 properties of charges, which is being asked almost every alternate year, right? So, this question is important, but properties itself are also important. First property is charges are additive in nature. What is the meaning of additive? Additive means like Fevicol gum, right? So, if you add one on another, they get merged, right? So, Fevicol gum is an additive. So, similarly charges are also additive, but one thing is that Fevicol can add only positive with positive, but charges can be added with negative as well. Okay. So, that is one difference. So, charge can be added algebraically. Algebraically means, what is algebra? Algebra says 2 plus 2 equals to 4. This is the algebra. Okay, but 2 plus 2 is not always 4 if you consider vector quantities. So, that means charge is a scalar quantity. So, if 2 plus 2 equals to 4 is happening, that means you can guarantee that this is basically a scalar quantity. Similarly, 2 plus 1 should be 5, okay, 2 plus 2 minus 1 should be 3. Okay, so charge can be added like an algebraic method, plus, minus, everything you can consider. If total negative is more than total positive, then the answer will be in negative. Okay, the 6th class math, I think 6th class you have learned it, or maybe 5th class. Okay, there you have studied on positive and negative addition. So positive and negative addition, that same thing you are learning again in your second PU. So this is as easy as that. Don't get confused. Charges can be added. So one example is given here. Q minus 2Q plus 3Q is actually equals to 2Q. Right? Charges are basically like algebraic method. You can simply add them. Next property is another easy property, which is charges are conserved. Now there is a important point to remember. Okay, the total charge of an isolated system is always conserved. Isolated system means it is not in contact or not in touch with anything else. Okay, it can neither exchange particles or it neither exchange anything that is already inside this object. So that is called isolated system. Isolated system means you pack something inside your bag, you close the bag and you are not going to open it, then that bag can be considered as an isolated system. Okay. Now you might be thinking that why it is on isolated system, because so total number of positive and negative charge, if it is a neutral object, positive and negative charge should be equal. If it is not a neutral object, even if it is isolated, the charges will always remain same. Okay, charge cannot create or destroy itself in extra numbers. Charges can be created or destroyed. Yes, charges can be created or destroyed, but remember, extra amount of charges cannot be created. Charges can be created always in pairs. Okay, so if you create charge, one positive, one negative will be created. Okay, so that is how charge initially when universe was created during the Big Bang process. Okay, charges are actually created out of nothing. Okay, and then hydrogen was formed, and slowly after hydrogen many other elements followed. But remember that even if you can create charges, charge will be created in equal amount. So positive and negative equally will be created. So total positive, total negative might change, but if you add positive and negative together, the total net charge, the net charge will be constant. And net charge will be constant only for isolated system. If the system is open system or any system, so there is a question in PU exam. Okay, charges are conserved for all systems, any systems, open system, isolated system or closed system. Sometimes it is also called closed system. So you have to be careful, you should not write all systems. It is only conserved for an isolated or closed. Okay, sometimes isolated term is also used as closed system. Closed system means it is not exchanging anything with anything else. Okay, that's why it is called isolated system. So charge is conserved only for isolated system. It is not conserved for any system. Okay, or all systems. It is not possible to create or destroy net charge carried by any isolated system, although the charge carrying particles may be created or destroyed. So as I mentioned, if you are creating from energy, if you create charge, which happened millions of billions years ago during the Big Bang. Okay, if you create a positive charge, you will get an equal amount of negative charge. So positive and negative charge can be created using energy, but positive and negative total charge will always be zero. So isolated system have a constant amount of charge. Okay, it cannot be increased on its own. Okay, that is very, very important. Now third property is very complicated, which says that charges are quantized. Okay, quantized is something you may not have heard it before. Quantized means quantity. The term comes from the quantity or quanta. Quanta means it has a fixed amount. Quanta means it is a fixed amount. Suppose you visited a milk shop. Okay, you visited a milk shop where the milk is being sold in 1 liter packets. Okay, the milk is sold in 1 liter packets. You require say 1.5 liter of milk for some payasam in your home. Okay, so you visited the shop and you asked, uncle, I need 1.5 liter milk. So what the shopkeeper will tell you, he will say, we do not have 1.5 liter, you either have to buy 1 liter or you have to buy 2 liters, right? So you will not be able to get 1.5 liter milk that is required. So you have to, you basically have to buy 2 liters, right? So imagine the same thing happens in our charge world, okay? So in charge world, when you come, you will basically see that each charge has that fixed amount of charge. So if you require something in between, you will not get that, okay? So the minimum amount of charge that is possible is given by 1.6 into 10 to the power of minus 19 Coulomb, okay? Minimum charge that is possible is 1.6 into 10 to the power of minus 19 Coulomb. This is actually the charge of one single electron, okay? You cannot have half electron charge, or you cannot have 1.5 electron charge, or you cannot have any fractional amount of electrons. Electron is a whole number, okay? Charge of an electron is a whole number. So whenever you are considering the charge of an object, the charge of an object can be written as Q equals to N into E, where N is an integer value. N is a integer number, okay? Integer means 0, plus minus 1, plus minus 2, plus minus 3, etc. Plus and minus both is possible, but plus minus 1.1, 2.5, 3.6, those values are not possible. So decimal number is not possible, only integer values are possible, okay? Only integer values are possible, and this N is actually an integer, okay? So all free charges are integral multiples of a basic charge denoted by small e. Integral means basically integer multiple, okay? Integer itself is not used, so instead of integer we use integral multiple, okay? Integer is a thing which is a set which is denoted by this, okay? And integral multiple means basically the numbers are integers. That is the meaning of this. Integral multiple means the numbers, the multiplicative factor is integer, 1, 2, 3, 4, 0. 0 is also an integer, by the way, okay? So all charge can be written as an integral multiple of small e. Small e is the charge of an electron, which is denoted by 1.6 into 10 to the power of minus 19. Now if you are given some few sets of charges and they ask you what is the which of the charge is not possible, you have to find the charges by dividing by this factor, and if the answer is a decimal number, then the decimal number answer is not possible. There was one example given in your model question bank released by your state board. So the charges are given 1.6, 3.2, okay, 4.8, and I believe was 6, okay, or I think 5.4. Okay, now if you see that 1.6 into 1.6 is 1.6, okay, 1.6 into 2, 1.6 into 2 is 3.2, 1.6 into 3 is 4.8, but 1.6 and 5.4 is not a multiplied. So this is a fractional number, okay? This is a fractional number which is actually turning out to be 1.6 into 3.5. So this value is not possible. So make sure all of them will have definitely 10 to the power of minus 19 multiplied, okay? So that is given. But this factor is not coming out as an integer fraction, so that means this is not possible. So be careful, such kind of easy questions might come, and if you are not careful you will lose marks. So all of them looks like possible but not possible because this factor is a decimal number, okay? Now let's see one more type of question. If a charge on a body is 1 nanocoulomb, then how many excess electrons are present in the body? So there is one very neat trick I will teach you, okay? Not NEET neat, NEAT neat trick, okay? Clever trick to solve such questions, okay? So first thing you have to check whether the given charge is a multiple of 1.6 or not, okay? So if the charge is multiple multiple of 1.6, the method is number 1 method, okay, number 1 method. And so if the multiplier of 1.6, for example 3.2, 4.8, 6.4, they are multiplier of 1.6, so for them we will use method number 1. And if it is not multiplier of 1.6, so if it is not multiplier of 1.6, then we will use method number 2. So both are shortcut methods. Remember, you can use method number 1 in general, but method number 1 in general can be difficult if the charge is not integer multiple of 1.6. So for this we are going to use q is equal to NE, okay, and n equals to q by E. This is the method. It's very simple. Charge is given 3.2, you divide it by the charge of an electron, 1.6 into 10 to the power of minus 19, you calculate the amount of charge. But here if you see, this is not given as 1.6 multiples. It is a general number 1. 1 nanocoulomb, 2 coulomb, 5 nanocoulomb, 10 coulomb, 10 microcoulomb. So in those cases, the method number 2 becomes very, very handy, where you directly calculate the number of charged particles. Okay, so directly how to calculate the number of charged particles? It is given by, obviously, first is the charge itself. So 1 nanocoulomb, nanocoulomb means 10 to the power of minus 9. The charge itself multiplied by 6.25 into 10 to the power of 18. Basically, remember, 1 coulomb of charge is actually 6.25 into 10 to the power of 18 electrons. Okay, so if an object have 1 coulomb of charge, the excess electron in that object is 6.25 into 10 to the power of 8 extra electrons. Okay, so the object will have 6.25 into 10 to the power of 18 extra electrons. So if the excess charge is 1 nanocoulomb, you just need to multiply this factor with 1 nanocoulomb. If the charge is 10 microcoulomb, you might multiply this factor with 10 microcoulomb. That's it, right? So here you just need to multiply and you will get 6.25 into 10 to the power of 9. So the excess amount of charge is 6.25 into 10 to the power of 9. So correct answer is option D. Okay, correct answer is option D. Right? Now let me have some water, please. Now let's move on with the next and last concept of the day, which is Coulomb's law. Okay, Coulomb's law is basically, before going into Coulomb's law, you need to understand the one very basic thing, which is called point charge. In most of our discussion, we will say the charge is a point charge, or it will say that one point charge is kept there, one point charge is kept there, here and there. So what is the meaning of point charge? Is it a simple point? So simple point is obviously is very, very small. So we in physics, we define a point charge, which is actually not a point, but the size of the charged object is smaller compared to the distance. So if the size of the object is smaller compared to the distance, then we consider it to be a point charge. Simple. So if the distance is large, size is small, we can consider it to be a point charge. It can be a sphere, it can be a box, it can be anything, but if the distance which we are considering is comprehensively bigger than the size of the object, then that sphere can also become a point. Okay? So it is not restricted to a simple single point, it can be an extended object as well. Okay? But as long as the distance is large, we can consider that object to be a point charge. Very simple. So now let us move into the statement of Coulomb's law. The force acting between, so first of all we know that like charges attract, like charges repel, unlike charges attract. So attraction and repulsion basically represents forces, right? So two opposite charges, they attract, that means they are feeling a attractive force. Okay, to similar charge they are getting repelled. Repelled means repulsive force. Okay. So whenever some attraction and repulsion happens, that means there is a force acting on it. So Coulomb is the first person who actually give a formula or a mathematical expression as well as a theoretical background how these forces acting. Okay. So he said that the force acting between 2 point charges is number 1 directly proportional to the product of the magnitude of the charges, inversely proportional to the square of the distance between the charges, okay, not over the force acts along the line joining the charges. So this is very, very important. So all 3 points you have to mention if they ask you state and explain Coulomb's law. Statement is this, explanation will come. So this is also very, very common question in PU exam, final board exam, midterm exam, unit exam, quarterly exam, whatever exam you can call. This is one of the most common concept which is being asked again and again. Okay, almost every year there is a question based on Coulomb's law, directly, indirectly. Coulomb's law, vector form of Coulomb's law, both are super important. We will discuss vector's law as well. But remember that statement is very simple. Charges, force between 2 charges is directly proportional to the product of the charges, inversely proportional to the square of the distance between the charges, and force acts along the line joining the charges. That is the point that many students miss. Okay, force acts along the line joining the charges, right? Now let's move on. Next is explanation of Coulomb's law. So here we have 2 charges Q1 and Q2, and they are separated by a small distance small r. Okay, 2 charges Q1 and Q2, they are separated by a small distance, they are separated by a distance small r. Okay, so what will be the force between these 2 charges? The force between these 2 charges, according to Coulomb's law, Coulomb said that the force acting between 2 charges is directly proportional to the product of the charges, and it is inversely proportional to the square of the distance, right? So both are proportional to each other. Okay, so when a quantity is proportional with 2 different quantities, we can say that that force is proportional to multiplication of these 2. So that is Q1 by Q2 divided by r square. So you have to multiply these 2. So one is in division, so that's why we are writing in division. Okay, so basically this is the proportionality theorem. Now if you want to remove this proportionality sign, you have to add a constant, right? Constant of proportionality. So that proportionality constant here is called Coulomb's constant. Okay, so if you remove this proportionality constant, you get the formula F equals to K Q1 Q2 by r square. So here we have added a modulus sign because we are only finding the magnitude of the force, not positive or negative. Force direction is okay, but negative force means opposite direction. So direction we are not interested as of now. We will come to the direction in a while later. Okay, so remember that magnitude of the force is basically proportional to the product of the charges and inversely proportional to the square of the distance, and if you multiply it with the Coulomb constant, that gives you the Coulomb force. This force is called Coulomb force, and this constant is called Coulomb constant, which is slightly complicated, which is given by 1 by 4 pi epsilon naught. Okay, and the value of this Coulomb constant as a whole is given by 9 into 10 to the power of 9 Newton meter square per Coulomb square. So this constant, you will have to remember this value. It will come in almost every problem, every numerical, every MCQ from this chapter when you are going to solve. That's why this value should be embedded in your head. If you have not yet remembered it, write it down in your notebook. This is going to be very, very important in all upcoming chapters. Not only in this chapter, in future chapters also, this constant appears again and again and again. And that's why in general we write it using a symbol of small k. Okay, small k is the symbol of Coulomb's constant. This quantity epsilon naught here is called permittivity of free space or vacuum. Okay, permittivity of free space or vacuum, its value is 8.854 into 10 to the power of minus 12 Coulomb square Newton inverse meter to the power minus 2. This value you may not need to remember, because if this value is required, generally provided in the question. Okay, if this value is required, generally it is provided in the question. Whatever value, sometimes it is written as 9 into 10 to the power of minus 12. Okay, but if it is required, it generally provided in the question. This value is not. So this value you have to remember. This value generally provided in the question. But with time, with practice, you will also remember this value as well. You don't need to worry too much. Now let's look into the Coulomb's law in vector form. This is very, very important for your PU exam, and also a question came based on this in 2024 KCET exam. Okay, sir, I need admission from, I don't read your comment properly, KCET from 12th. So menu edits, you can click on the link. I guess you want to take admission for our KCET paid batch. The paid batch link is given in the description of this video. Okay, if you just close the live chat, go there, click on more. Okay, and there is a link, say read more. Click there and you will be seeing the first link. Okay, secure your rank in KCET 2027 with Pariksha Veera Prime. So you can join by clicking on that link, right? Minu, I guess your doubt is cleared. My live chat is disappeared. Okay, right, Minu? So if you are willing to join our Pariksha Veera Prime batch, close the live chat, go into the chat section, click on the read more. There you will get the link from where you can join the batch. Okay, classes will start from 15th of June onwards. So now Coulomb's law's vector form is very, very, very important in your PU exam. Okay, so this question, and also it came once in your final KCET exam as well. We will show that question as well. So what is the vector form? Basically they will say that explain Coulomb's law's vector form. Now Coulomb's law vector form, very important point to remember, the diagram is must. So if you are writing the question in your PU exam, the diagram is must. Without diagram, Coulomb's law's vector form has no meaning. So write the Coulomb's law in vector notation, explain the terms. So basically the explanation itself happens through the diagram itself. So first you have to take an origin. Okay, O is an origin. Okay, the charge Q1 is located at a distance R1 vector. Charge Q2 is located at a distance R2 vector. Okay, then the force between Q1 and Q2 in terms of vector notation can be written as F vector 2-1 equals to K Q1 Q2 by R square R vector 2-1. So what is R vector 2-1? R vector 2-1 is basically a vector pointing from 1 to 2. Okay, and if you write F12 will be K Q1 Q2 by R square R12 vector by R. Okay, or R12, you can write R12 cap also. R12 cap is basically R12 vector by R. Okay, so you can write in terms of cap unit vector, or you can write in like this as well. Okay, now remember that. So basically for this it is pointing in this direction, for this it is pointing in this direction. That is why the sign is opposite for the unit vector. That means we can write very simply F12 is equals to minus F21. F12 is equal to minus F21. This is a fact, comes from our old grandfather Newton. Okay, Newton's third law. Okay, so if this is action, this will be reaction. Action and reaction acts in the opposite direction. That's why there is a negative sign. So negative sign comes from the fact that it is based on Newton's third law. Okay, and whenever you write Coulomb's vector form, always remember that you have to write the you have to draw the diagram. Okay, so diagram is compulsory. Without diagram, you will not get marks. Now let us see one question that came in KCET in 2024. Not super long. Okay, this question is as recent as 2 years back. A point charge A of 10 microcoulomb and another point charge B of 20 microcoulomb are kept 1 meter apart in free space. The electrostatic force on A due to B is F1 and the electrostatic force on B due to A is F2. Then which of the following relationship is correct? So we know that if two charges are fixed, Q1 and Q2, no matter whatever is their magnitude, okay, whatever force acting on this is F1, this is F2, they must be equal and they must be in opposite direction. Okay, they must be equal and they must be in the opposite direction. So the correct answer is F1 equals to minus F2. So minus F2 represents the direction is opposite, and equal sign obviously represents they are equal. So it is not 2 or 1, simple, do not write this one, obviously this is a trap, it has to be negative sign. Okay, this comes from the Newton's third law. Okay, now let's move on. Coulomb's law in dielectric medium. This is something which is a KCET specific topic, KCET and NEET or JEE specific topic. This topic will not come in your PU exam. So far whatever you have discussed, it is common for KCET and PU, but this topic is KCET specific. So two charges are there, Q1 and Q2, okay, and if you take this charge inside a dielectric medium, dielectric medium means, for example, you can consider water to be a dielectric medium, okay, and if you freeze it to ice, ice will also become a dielectric medium. So anything other than air can be considered as a dielectric medium. Metals are excluded, okay, metals other than metals and air, anything you can consider insulating mediums, basically considered as dielectric medium. You can use a wooden log, okay, block of wood, you put some charge inside the wood, that will also be considered as a dielectric medium. Okay, so you take two charges, you put it inside a dielectric medium, say glycerin, you put the charges inside the glycerin. So what will happen to the Coulomb force? Will it remain same when it was in air, or it will increase or it will decrease? That is our question. And one more point is, if you partially fill it with a dielectric medium, not the entire charges, if you partially fill it, then what will happen? So this is slightly tricky, but this is easier. First we will understand what will happen if you take both charges and if you put it inside a dielectric medium. So dielectric medium of constant K. Now don't confuse, this is capital K, Coulomb constant is small k. Okay, that's why some students sometimes get confused. I use instead of K, you can write epsilon r as well. Okay, relative permittivity, or sometimes also called dielectric constant. Okay, so dielectric constant, say capital K. So if you put the both charges inside, what will happen? First of all, the Coulomb's law will not remain same. Coulomb's law is a force which depends on the medium. It is not independent of the medium. Like gravitational force, Coulomb's law does depend on whatever is between the medium. So it will be 1 by 4 pi epsilon naught, not epsilon naught, it will be simply 1 by 4 pi epsilon. Epsilon is the permittivity of this medium. Okay, permittivity of this medium. Remember, epsilon is basically given by dielectric constant into free space permittivity. Okay, so epsilon is not constant for all medium. Like gravitational force, the constant was called universal gravitational force, right? You have studied this in class 11th when Newton's law of gravitation was taught. Okay, so in that case you have learned that the formula was F is equal to G m1 m2 by r square, almost same formula, except for the fact G is called universal gravitational constant. Here it is called free space permittivity, which is different. That means it depends on medium, depends whatever is between these two charges. That one point you have to be very, very careful. So force between two charges is given by 1 by 4 pi epsilon q1 q2 by r square. Everything is same. This is Coulomb's law. Only factor that changes is the proportionality constant. The proportionality constant changes. Coulomb's law as it is not changed, only the proportionality constant changes. That's why the Coulomb force itself changes. So we can write this force as 1 by 4 pi k into epsilon naught q1 q2 by r square. q1 q2 by r square, or we can write 1 by 4 pi epsilon naught q1 q2 by root over of k into r whole square. Okay, now this form looks very similar to our Coulomb's law. Only thing is that the distance here appears to be increased. Okay, the distance is appear to be increased. This is called free space equivalent length. This is called free space or equivalent free space length or distance. Okay, so the free space equivalent length is nothing but root over of k into r. So as you can see, the distance, suppose you have 10 centimeter initial distance, the dielectric constant was 4. Okay, so dielectric constant, suppose let us take some value. So dielectric constant is 4, initial distance was 10 centimeter. Okay, so now if you put it inside this dielectric medium 4, what will be the new distance? New distance will be square root of 4 into 10, that is 20. So the new distance will be more than whatever was the initial distance. Only fact is this distance is in air, this distance in dielectric medium. So because the equivalent length increases, we say that when you have a combination of charge, you put it inside a dielectric medium, the force between them always decreases. The force between them always decreases. Now there is a homework problem. So the other second case I will give you as a homework problem. Suppose two charges are there, q1 and q2. The distance between them is small r. Okay, you fill some part, say a length x, inside a dielectric medium k. You immersed partially, or you put a mica sheet. Mica is a dielectric medium. You put a mica sheet of width x between these two charges. What will be the new force? Okay, what will be the new force? Try to answer this question and mention basic answer in the form of, you can write equation. You are not allowed to write equation, but you can write the basic form, how the distance will change. You basically find r dash in this case. If you are able to find r dash, you can find the force as well. So write r dash in the comment below. Okay. Now force between multiple charges. This is also a simple thing, that when we have multiple charges, say q1, q2, q3, q4, such we have n number of charges. They are all scattered in a space. Okay, it happens obviously. So what will be the force? Obviously there, so we have to take one charge first. We will take this charge as our origin charge or first charge, and we will try to find what is the force acting on this charge because of the other charges. So some of them can be positive, some of them can be negative. Okay, so basically the thing is very simple. You have to take the vector, force vector of all such pairs with 1, and then you add them vectorially to calculate the final force. It is not a simple algebraic addition. This is important when you solve numerical questions. Okay, numerical questions, these kind of things are being asked. So force is basically sum of all such charges. Okay, and it is basically q1 qn by r1n square. Okay, and obviously the Coulomb constant, I equals to 2 to n. Okay, I equals to 2 to n. So this is the formula. Basically you have to calculate all the forces and then add them vectorially. Okay, add them vectorially. This is very, very important thing to remember. Okay, we will in future we will learn a simpler method than this, but this is very important part, that whenever you are calculating force due to multiple charges, you have to add them vectorially. Vector addition is very, very important. So this is basically vector addition, not scalar addition. So this is very, very important point to remember. Now there is a homework question for all of you. So those who are watching live, or maybe you are watching at some point, sir, when just the ma'am next class, I miss previous class. So Anmol Singh, Jasmine ma'am is unwell today. I don't know whether she will be able to take her class tomorrow. So tomorrow is her scheduled class. If she is well and fit enough, she might take tomorrow's class, but if it is not happening, then maybe day after tomorrow. Okay, so tomorrow is our scheduled class, but maybe it get delayed by 1 or 2 days. Okay, so you will get an update. Okay, Anmol, follow our WhatsApp channel, follow our channel if you have not clicked on the follow button. Okay, whenever a class is scheduled, you will get a notification, right? So whenever a class is scheduled, all the live classes are generally scheduled in the morning itself, so that you can join in the evening, right, Anmol? I hope your doubt is clear. So this is a homework. So solve this homework and mention the answer. Option A 0, option B, option C, option D. Mention option as well as the correct answer. Okay. I will, if possible, I will discuss the solution in our next class. Okay. I will give you at least the solution for that. But if you mention in the comment below, I will definitely check and I will definitely reply back. Right? Sure. So this is the end of today's lecture, and if you really you are watching this channel for the first time, or if you have not yet subscribed, don't forget to subscribe, like this live class, okay? And if you are watching later on, leave your comment in the main chat section so that I can reply. I gave you 2 questions, one homework theory, slide theory, and one is homework question. So do solve them. And one very important point to remember, if you want to download the PDF of this lecture, okay, that will be available through our WhatsApp channel. We will share the link how to download this file on our WhatsApp channel. So it is a very earnest request to all of you, do join our WhatsApp channel. It was there, it was some of your seniors are still there in our WhatsApp channel, they do, and it is a channel, okay. So it is not like you can communicate, only it is for your update, okay, and it's an anonymous channel, so your contact details etc. will remain private. No one, including us, will not be able to see your contact details, so it will remain private to everyone, right? So do join the WhatsApp channel. The link of the WhatsApp channel given in the description section of this video. Close the live chat, click on the read more section. First is our Pariksha Veera batch link, second is our WhatsApp channel link. So do join the WhatsApp channel. There you will get all the updates, right? Anmol, whenever Jasmine ma'am is coming live, or I am coming live, or any other teacher is coming live, you will get the notification in our WhatsApp channel. Also the PDF links will be shared in our WhatsApp channel. We have not shared the bridge course link or any other previous classes link. We will definitely share it very soon. So don't forget to join the WhatsApp channel. It will be very, very helpful for all of you, those who are preparing for KCET or PU exam. Right? I will see you in our next lecture. If you have any questions, you can leave in the comment section. Till then, bye.